Atmospheric circulation drives Earth's wind patterns. It occurs due to uneven solar heating and pressure changes between the equator and the poles. Different parts of the Earth are warmer than others due to the difference of direct sunlight. The equator gets the most direct solar radiation, making the air hotter and less dense. This causes it to rise and create a low pressure area at the surface. The poles get the least amount of solar radiation, which makes the air there colder and denser, causing it to sink and make its way to the lower pressure surface. This is called convection. A physical representation of this will now be shown. In this representation, the red water represents hot air and the blue water represents cold air. As I add the cold water, you can see how it sinks immediately. The colder it is, the more dense it becomes, causing it to sink. When the hot water is added, it rises to the surface and remains there. As you can see, the two layers don't mix, and you can actually see the room temperature water remain undyed. Just like this water, cold and hot air works the same way in the atmosphere. The rising of hot air and falling of cold air creates circulation convection cells. Air near the equator rises, flows towards the poles, cools, and then sinks. There are actually 3 different circulation cells in each hemisphere, which are all driven by the motion and exchange of hot and cold air. Due to the Earth's rotation, different parts of the Earth move at different speeds. This causes moving air to curve. This is known as the Coriolis effect. Without the Coriolis effect, Earth would actually only have one large circulation cell in each hemisphere. The changes in temperature and pressure is what creates atmospheric circulation, so the next time you feel the wind, just remember that that's hot air rising and cold air sinking.